Namaskara, hello everybody and welcome back to my class. We are in a continued lesson of chapter 5 Understanding Elementary Shapes of class 6th. This is your fourth and final session of this lesson. Children, in the last class we have learnt how to find angles with the help of protractor and what are perpendicular lines and how to classify different types of angles based on their characteristics, isn't it? Do you remember this one I gave to you to do at home? Have you finished this work? You see here. Observe the method of finding angles using a protractor. If you drew lines in the same pattern, then only you can get these answers. If you drew lines in some other orientation, then you may get different angles. Now we'll find these angles one by one. First we'll find the angle RQS. For this, first we have to place the protractor on the line QS and we'll read the marking against the line QR on this protractor. See, it's showing 30 degree. So, angle RQS is 30 degree. Now, we'll find the angle RQT in the same manner. Now, we have to place the protractor on the line QR and we'll read the marking against the line QT on this protractor. See, it's showing 100 degree. So, angle RQT is 100 degree. Similarly, now we'll find the angle TQP. For this also, we have to place the protractor on the line PQ. For this, we have to measure from this side. Now we'll read the marking against the line QT. See, it's showing 80 degree, isn't it? So, angle TQP is 80 degree. We can find angle PQS in both the ways, either by using a protractor or in this way. See here, angle PQR is a straight angle and is 180 degree. We already know the angle RQS and is 30 degree. So, by subtracting angle RQS 30 degree by 180 degree, we'll get 150 degree. That is angle PQS. Is it clear, children? In this session, we are learning quadrilaterals, polygons and three-dimensional shapes or 3D shapes. Are you interested to learn all this? Yes. Let's begin our class now. First, we are learning quadrilaterals. The meaning of quadrilateral is quadri means 4 and lateral means side. So, any four-sided closed shape is a quadrilateral. Understood? Now, let's see how it forms. Place a pair of unequal sticks such that they have their end points joined at one end. Now, place another such pair meeting the free ends of the first pair. So, what is the figure enclosed? Yes, it is a quadrilateral like the one you see here. The sides of the quadrilateral are AB, BC, CD and DA. There are four angles in this quadrilateral. They are given by angle BAD, angle ADC, angle DCB and which is the next angle? Yes, it is angle CBA. And also we can draw lines from B to D like this and A to C. These are called diagonals. So, BD is one diagonal. What is the other? Yes, it is AC. You also draw a quadrilateral like this and measure the length of the sides and the diagonals. Measure all the angles also. Okay. Now, we have learnt what quadrilaterals are. Here are some statements through which we can understand the characteristics of quadrilaterals. Using four unequal sticks, as you did in the previous activity, see if you can form a quadrilateral such that, we'll see the first statement, all the four angles are acute. Children, think, is it possible to make a quadrilateral if all the four angles are acute? Let's try it. See here. Here all the 4 angles are acute. But is it a quadrilateral? No. So, it is not possible to make quadrilateral with all acute angles, isn't it? We'll see the next statement. One of the angle is obtuse. Can we make a quadrilateral if one of the angle is obtuse? Let's try. See here, angle ABC is obtuse angle, isn't it? So, we can make a quadrilateral with one obtuse angle, isn't it? We'll see the next statement. One of the angle is right angled. Can you make a quadrilateral if one of the angle is right angled? We'll see. See here, in this quadrilateral, angle DAB is right angle, isn't it? So, we can make quadrilateral with one right angle. We'll see the final statement now. Two of the angles are obtuse angled. We'll see, is it possible to make a quadrilateral if two of the angles are obtuse angled? Observe here. In this quadrilateral, we have two obtuse angles, angle BAD and angle ABC. So, we can make quadrilateral with two obtuse angles. Did you understand, children? You have two set squares in your instrument box. One is 30 degree, 60 degree, 90 degree set square. The other is 45 degree, 45 degree and 90 degree set square, isn't it? Use these two and try to make quadrilaterals. Children, we can make quadrilaterals with these two set squares. But we need two pairs of set squares to make quadrilateral using these set squares. Children, square is also a quadrilateral. See, if you arrange set squares in this manner, you will get this shape. What is the shape? Yes, it is a square shape. So, if you use a pair of 45 degree, 45 degree, 90 degree set square, you get a quadrilateral. It is a square. Are you able to see that all the sides are of equal length? What can you say about the angles and the diagonals? Children, square is a type of quadrilateral in which all four sides and all four angles are equal, and even diagonals are also equal in their lengths. Here are some examples for square which we see around us in daily life. See, it's a square. In this picture, you can observe square shaped objects, isn't it? See here. Observe the shape of this tree. Is it not square shaped? Yes. And the signboard, this is also in square shape. And the wooden logs are also in square shape. Usually, tiles are in square shape only. So, children, like this, you can also list out square shaped objects you see around you. Another type of quadrilateral is rectangle. If you arrange your set squares in this manner, you will get this shape. The shape formed is called rectangle. So, if you use a pair of 30 degree, 60 degree, 90 degree set square, you get this type of quadrilateral. It is called as rectangle. Are all the sides are equal in this? What can you say about the angles and the diagonals? Children, rectangle is a type of quadrilateral in which opposite sides are equal and all four angles are equal, and even diagonals are also equal in their lengths. Understood, children? Here are some examples for rectangle shaped objects which we see in day-to-day life. Photo frame is there, brick is there, and building design you see, and signboard, that's also in rectangular shape, and blackboard, duster, and even your mobile, notebook, and your instrument box. Everywhere you can find rectangular shapes around us, isn't it? Parallelogram is another type of quadrilaterals. Now we will learn about parallelogram. If you arrange your set square in this pattern, you will get this shape. The shape formed is called a parallelogram. If you use a pair of 30 degree, 60 degree, 90 degree set square in different position, you get a parallelogram. Do you notice that the opposite sides are parallel? Are the opposite sides equal? Are the diagonals equal? A parallelogram is a quadrilateral with opposite sides parallel to each other. Here are some examples for parallelogram we see in our day-to-day life. Here some patterns are there and Rangoli pattern is there, you can observe here. Another type of quadrilateral is rhombus. Now we'll study about rhombus. If you arrange your set squares in this manner, you will get this shape and it is a rhombus. So, a rhombus is a quadrilateral with opposite sides parallel to each other and the diagonals bisect each other at right angles. It is also called a diamond or rhombus diamond. Here we have some examples for rhombus shaped objects which we see around us in our daily life. See here, crystalline structure of sulfur, you can see rhombus, and the cutting of diamond, you can observe here, it's a rhombus diamond, and this pattern, you can see rhombus shape, and Rangoli pattern, usually we see in our Rangoli. We can find rhombus shape in many sweets also, isn't it? Trapezium is another type of quadrilateral. Now we'll learn about trapezium. If you arrange your set squares in this pattern, then you will get this shape. So, if you use several set squares, you can build a shape like the one shown on the screen. Are you able to see that all the sides are of equal length? What can you say about the angles and the diagonals? Children, trapezium is also a type of quadrilateral in which a pair of two opposite sides is parallel. It is a trapezium. Children, till now we have learnt what quadrilaterals are and different types of quadrilateral. To understand and verification, now I will give you one activity. It's just a true or false type. You read the statements and tell me whether the given statement is true or false. Okay. First statement. Each angle of a rectangle is a right angle. Is it true or false? Yes, it is true. We'll see the next statement. The opposite sides of a rectangle are equal in length. Is it true or false? Yes, this is also true. We'll see the next statement. Diagonals of a square are perpendicular to each other. Is it true or false? Yes, this one is also true statement. We'll see the final statement. The opposite sides of a trapezium are parallel. Is it true or false? Think. Yes, correct. It is false because only one pair of a trapezium is parallel. Let's do another activity. A figure is said to be regular if its sides are equal in length and angles are equal in measure. Can you identify the regular quadrilateral? Is it a square, rectangle, rhombus, trapezium or parallelogram? Yes, it is a square. You see here, all the sides are equal. So, square is a type of quadrilateral in which all four sides and all four angles are equal and even diagonals are also equal in their lengths. Isn't it, children? On the whole, we can make an outline summary of quadrilaterals as shown on the screen. So, we have 5 types of quadrilaterals: parallelogram, rectangle, square, rhombus and trapezium. Now, we'll see the characteristics of these quadrilaterals one by one. In parallelogram, opposite sides are parallel and they are equal also. All sides are not equal. Opposite angles are equal. Diagonals are not equal and they are not perpendicular. In rectangle, opposite sides are parallel and they are equal. All sides are not equal and opposite angles are equal. And diagonals are also equal but they are not perpendicular. In square, opposite sides are parallel and they are equal. All sides are equal. Opposite angles are also equal and diagonals are also equal and they are perpendicular too. In rhombus, opposite sides are parallel and equal also. All sides are equal and opposite angles are equal. Diagonals are not equal, but they are perpendicular. In trapezium, only one pair is parallel, but they are not equal. All sides are not equal. Opposite angles are also not equal. Diagonals are also not equal, and they are not perpendicular also. Now we will study about polygons. Children, observe here the shape formed with straight lines and vertices. See, it's a quadrilateral ABCD, isn't it? And it is a polygon. Children, a polygon is a two-dimensional shape formed with straight lines. The shapes consist of 3 or more than 4 sides. See here, it's a rectangle and also it's a closed plane figure. Two-dimensional means only length and breadth. So we can measure only length and breadth of this shape. Understood? So it is a two-dimensional shape. Here in this we cannot find depth or height of this object. Now try to extend the idea of polygon to figures with more number of sides. We may classify polygons according to the number of their sides. Three-sided polygon is named as triangles. Here tri means 3. So these are all three-sided polygon, and four-sided polygon is called as quadrilaterals. We have just learnt about quadrilaterals, different types of quadrilaterals, isn't it? Here quadri means 4, and five-sided polygon is named as pentagon. And the shape of the pentagon you can observe here. How many sides it has? Yes, it has 5 sides. So penta means 5. Similarly, six-sided polygon is named as hexagon. You can see the picture of hexagon here. If you count the number of sides in this figure, you will get 6. So hexa means 6. Similarly, seven-sided polygon is called as heptagon. So the shape you can see here. If you count the number of sides, you will get 7. So hepta means 7. Like the same, 8-sided polygon is called as octagon. And the shape you can see here. If you count the number of sides, you will get, yes, 8 sides. So octa means 8. Like the same, 9-sided polygon is called nonagon. And 10-sided polygon is named as decagon. Here you can see the shape of this decagon. Let us count the number of sides in this. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So deca means 10. Children, till now we have learnt what polygons are. Now let us do an activity. Identify the polygons from the following figures. First one is, yes, it is a polygon. It's a three-sided polygon and it's a closed plane figure also, isn't it? And what about the second one? Is it a polygon? It's a closed figure, but it's not a polygon because it is made by curved lines. It's not made by straight lines, isn't it? So we cannot call it as polygon. And the third one you observe here. Even though it is made by straight lines, we cannot call it as polygon. Think why? Because it's an open figure and not a closed figure. So we cannot call it as polygon. And the fourth one you observe here. It's a closed figure, it's made by straight lines and it's a plane figure also. Can we call it as a polygon? Yes, definitely it's a polygon. And the fifth one, yes, obviously it's not a polygon because it's made up of a curved line and it is a circle. And the sixth one, yes, you have just studied about this. It's a pentagon and it is a five-sided polygon, isn't it? Now let us understand what are three-dimensional shapes. So, three-dimensional shapes are the shapes with three dimensions such as length, breadth and height or depth. So, we can define 3D shapes like this. 3D shapes are solid shapes or objects that have three dimensions which are length, width and height or depth. Children, here you observe it's a two-dimensional figure and it is a circle, and you observe here it's a three-dimensional figure and it is a sphere. You can observe and compare between these two the size, shape, height of this 2D and 3D figure. Children, you see here it is a 2D figure or two-dimensional figure. It is a square, and this one is a cube and it is a three-dimensional figure, isn't it? So here we have two-dimensional square and a three-dimensional cube. You can compare between these two. In this two-dimensional shape, we can measure only length and breadth. So this is two-dimensional. And in this three-dimensional shape, we can measure length, breadth as well as depth or height of this object. Is it clear, children? So two-dimensional and three-dimensional. You can compare and find the difference between these two shapes. Okay. See, it's a rectangle and it's a two-dimensional figure, and it is a cuboid. We call it as cuboid, and it is a three-dimensional figure. Here also you can compare two-dimensional and three-dimensional rectangle and cuboid. So in two-dimensional we can measure only length and breadth of this shape, but in three-dimensional we can measure length, breadth as well as height or depth of this object, isn't it? Is it clear, children? You can observe difference between two-dimensional and three-dimensional figure in this picture also. It's very funny, no? Now we'll see some three-dimensional shapes on the screen. See, it's a cube, cuboid, cylinder and pyramid and a sphere. These are examples for three-dimensional shapes. We can count number of faces, edges and vertices of three-dimensional figures. Let's see how. For example, let us consider a cube. Each side of the cube is a flat surface called flat face or face. Two faces meet at a line segment is called an edge. You can see here. Three edges meet at a point is called a vertex. So you can observe here three edges meet at a point is called a vertex. See, it's a pyramid. A pyramid is a shape with a square base and the other faces are triangles, isn't it? Now let us count the number of faces, vertices and sides of this cube using this cube model. Okay. First we'll count the faces. How many faces are there? Yes. It has one top face, bottom face and four faces around, isn't it? So totally 6 faces are there in this cube, isn't it? Now let us count how many vertices are there. So 4 vertices on the top face and 4 vertices on the bottom face. So totally we have 8 vertices. And let's count how many sides are there in this cube. So 4 sides are there on the top and 4 sides are there on the bottom and 4 sides around, isn't it? So in total we have 12 sides. Is it clear, children? We'll see the next one. See, it's a cuboid. Let us count number of faces, vertices and sides of this cuboid using this cuboid model. Okay. Now first we'll count number of faces of this cuboid. So it has one top face, bottom face and 4 faces around. So in total it has 6 faces. Now we'll count how many vertices are there in this cuboid. So it has 4 vertices on the top face and 4 vertices on the bottom face. So Totally 8 vertices are there in this cuboid. And how many sides? Let us count. 4 sides on the top and 4 sides on the bottom and 4 sides around. So in total 12 sides. Did you understand, children? We'll see the next one. See, it's a square-based pyramid. Now let us count number of faces of this square-based pyramid. Let's count. 1, 2, 3 and the front one, 4 and the square base, it's 5. So in total it has 5 faces. Now let us count number of vertices in this square based pyramid. See, 1, 2, 3, 4 and 5 vertices are there. Isn't it? Now let us count number of sides in this square based pyramid. So 1, 2, 3, 4, 5, 6, 7 and 8. So 8 sides are there in this square based pyramid. Now let us count number of faces, vertices and sides of this triangle based pyramid. Okay. So how many faces are there? 1, 2 and the front one 3 and the base 4. So it has totally 4 faces. And how many vertices are there? Yes, 1, 2, 3 and 4. So 4 vertices are there. And how many sides are there? Let us count. 1, 2, 3, 4, 5 and 6. So in total we have 6 sides in this triangular pyramid, isn't it? Now finally we'll count number of faces, vertices and sides of this prism. First let us count number of faces. How many faces it has? 1, 2 and 3, 4 and the base 5. So it has 5 faces. Now we'll count vertices. How many vertices are there? 1, 2, 3, 4, 5 and 6. So in total 6 vertices are there, isn't it? So finally we'll count number of sides in this prism. How many sides are there in this prism? Let us count. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9 sides in this prism. I hope you have understood 3-dimensional shapes very clearly. Now we'll do one activity regarding this 3-dimensional shapes. On the screen you are seeing some 3-dimensional shapes and their names. What you have to do? You have to match the 3-dimensional shapes with their names correctly. Okay? Write down and answer it. Now I will show you the answer. You verify your answers with this one. Okay? First, yes. See, it's a cylinder. Cuboid. This is a pyramid. It's a cube. Sphere. And this one is a prism. Did you understand, children? Now it's time to give you home assignment. What shape is your instrument box? What shape is a brick? What shape is a matchbox? And what shape is a road roller? And what shape is a sweet laddu? I hope you will do it today itself. Okay? Children, in this session we have learnt quadrilaterals, polygons and 3-dimensional shapes. I hope you have understood very clearly. And this is the last session of this lesson. If you have any doubts, please go through the previous videos of this lesson and understand better. Now it's time to say bye to you all. See you in the next class. Till then, stay home, be safe and don't stop learning. Thank you by P.S. P. Sunita, TGT, GMPS, Jaraganahalli, Bangalore, South 3. Thank you.